Okay, I want to do a couple of additional problems a little bit different than the ones we did with the disc and washer. They're still disc and washer type problems as we're rotating around a line, but what we're going to focus on here, or do a couple of things just to make sure we understand, is we're going to rotate them around a line that is not the X or Y axis. So everything we did before was around the X axis or the Y axis, but it's reasonable that we could rotate it around some other line. So let's see what that means. Okay, here's a problem, well, at least a graph we did before. It's a triangular shape between the X and Y axis and the line X plus 2Y equals 2. But what I set up here is now we're going to rotate it around Y equals 1. So think about where Y equals 1 is. That is up here. So we're going to rotate it around there. Okay, so when we look at that, that means that we're going to come out from there to a far radius, and we're going to come into a closer radius. So there's an outer radius and an inner radius when we do it this way. So this is definitely a washer. Okay. So a washer, because there's going to be a gap there. So let's see, what does the volume look like? And we'll make sure we work this out. But a washer method here, pi, and we need some endpoints. Where we're going around Y equals 1, but Y equals 1 is parallel to the X axis. So we're going to do everything in terms of X. Okay, that may sound counterintuitive, but remember the X axis is also Y equals 0. Okay, so let's see here. We're going to do everything in terms of X. So let's go ahead and take our thing here, which is 2x plus 2y equals 2, and let's solve it for to get y by itself. So we'll have 2y equals negative x plus 2, and then we'll have y equals negative 1/2 x plus 1. So that's another name for the line cutting across there. Okay, but if we use that, then we're really doing a distance between the x-axis and the line. So if we talk about using this line right here the way it is, the y distance comes up to here. But what we're really trying to do is do the distance up above it. So we got to be kind of careful there. So let's see if we can make sure we get what we want. So based off of what we got, the outer radius comes from this line of rotation all the way out to the outside, which is down here. Now I said that was y equals 0, but what's that distance? That distance is 1. So the outer radius is 1 the whole time, so the outer is 1 squared. Okay, so from up here all the way down is 1. Okay, now from the line of rotation down to the y equals negative 1/2 x plus 1, how are we going to find that? Because the negative 1/2 x plus 1 gives us the distance under the curve. Well, if all the way out is 1, then this guy up here is 1 minus that negative 1/2 plus 1. So let's clean that up. So 1 minus negative 1/2 x plus 1. So that would be a positive 1/2 x, and 1 minus 1 would just go away. Okay, so distribute the negative through here. So this inner radius, if I clean it up a little bit, I'm going to subtract it out, but it'll be 1/2 x, and that radius will be squared, so that's the inner. These problems are a little bit harder because you've got to figure out how that works. So this inner radius right here will be 1/2 x, and that's the distance between the line down to the curve. So think about it. When x is 2, half of x is 1, which is how far that inner radius is. When x is 0, then 1/2 x is 0, which is how much this inner radius is over here. So after we have that, and we decided it was running an x, so we can run it from 0 to 2, it becomes a very easy problem once we set up. So pi integration from 0 to 2 of 1 minus 1/4 x squared dx. So that's pi times x minus 1/12 x cubed from 0 to 2. So let's see here. We'll let x equal 2, and we'll subtract off letting x equal 0. So x equals 2 will give me 2 minus 1/12 times 8. And then 0 will give me pi, forgot the pi, times 0 minus 0. So this whole last part just goes away. But what have we got here? We've got 2 minus 2/3, and that's times pi. So that's 4/3 pi. Seems like we saw that number somewhere before, but that's probably coincidental. But that would be if we took this thing and rotated it around the y equals 1. So what does that look like? Well, we've got the triangle shape down here, and if we rotate it, it'll be a similar triangle shape up here. But keep in mind that it's a rotation, so it's kind of like a three-dimensional figure here. Okay. So the outside of that thing. I'm not very good at drawing these. All right, let's try another one.